For my first module, I wanted to investigate two research questions using the general linear model. First of which is how well does interoception, or the accuracy of predicting internal heart rate, predict anxiety? The second question will use two predictors, and that is how well does depressive symptoms and emotion regulation predict anxiety using the GLM. I'm first going to extract univariate models and look at the distributions of each variable on its own. Then I'm going to use a bivariate regression model looking at interoception predicting anxiety. And then lastly, I will be looking at depressive symptoms and emotion regulation as predictors for anxiety. Just to refresh from last semester, the GLM lives on several assumptions. One is that X and Y are linear, that there are no errors or that no relevant variables got omitted, that there's a homogeneity of variances or that there's no multicollinearity, that the average model error is equal to 0, that the dependent variable is uncorrelated with error terms, and that all variables have normally distributed residual. I first plotted all the relevant variables that will be used during this module. As you can see on the top row, we have anxiety, that's our dependent variable, and we can look at the correlation it has with each independent variable or predictor variable. So notably, interoception and anxiety have seemingly a strong correlation with each other. Depressive symptoms and anxiety looks like there may be one guy out here that is an outlier. Similarly, emotion regulation, anxiety, there may be some outliers. And then our factor of sex, you can see there's two straight lines, which seems weird, but we can investigate that further on. We first pulled our variables that will be running for the bivariate regression model and looked at their distribution on their own. Notably, anxiety or outcome variable has normally distributed variance in about the first 100 observations. However, the second 100 observations, the variance seems to be more widespread. That begs the question, was there a different person asking the questions for the first 100 than the second 100 participants answering the questions? However, our best guess of anxiety is 5.6 with a standard deviation of 7.24. Additionally, interoception, our predictor variable, has some shared common variance in the first 100, 150. However, our residual or variances do get more widespread in the second 200 observations. However, our best guess of interoception is 8.1 with a standard deviation of 8.3. Here's another graphical representation of our variables and their distributions on their own. Just another way to look for potential outliers. However, everything on the histogram plots looks relatively normal. There are some high frequencies of scores, but nothing too concerning. This is a plot of our bivariate model that evaluates outliers that have outside influence on our model conclusion, which tells us the suitability of the data given our model. At the naked eye, it doesn't look that there are many outliers or any outliers that fall within the Cook's distance Wistar line, which tells us the impact that a variable has on our data. This is a bivariate regression summary model. This tells us how well does interoception predict anxiety. On the left is an unstandardized model. As you can see, it tells us down below our intercept. So when x is 0 or interoception is 0, we can expect our y value to be negative 0.94. That is the start of our line. Down below is the rise over run, or our betas, or our coefficient determination. This tells us how much increase we expect in y for every increase in x. So it tells us how much the variance of y can be explained by x. And that's at 0.8, which is a pretty strong slope of our line. Similarly, down below our r squared, that is just our y predicted minus our y observed, and that's 0.85. So that shows a strong multiple r squared, which when adding more predictors might be a concern because the r squared between the bivariate, just one predictor, and our outcome is high. On the right over here, we standardize both are predictor and outcome variable, and Shields as 2019 talks about the standardization of input variables, or simple means to improve the interpretability of regression coefficients. Further, reading the model with a slightly modified model structure allows extracting the appropriate standard errors for treatment groups directly from the model. You can see our coefficient of determination actually got stronger when standardizing the variables. So our coefficient, or our betas, are fighting over the variance, 92% of the variance. So it's a highly covariate model. Here's a graphical representation of the bivariate regression summary model shown on the previous slide. You can see this is our slope, or this is the expressed in the amount of change in y per unit change in x, and that gives us our 0.8 coefficient. Our steepness of the line. Our intercept is not important given the questions that we're asking. This is a scale location plot of our bivariate model. And this gets rid of any negative values but allows for the width of the distribution to not change. As you can see, our low S curve line is not strongly impacted by many values, so there's not much concern about this. Now we will move on to our second research question: how well does emotion regulation and depressive symptoms predict anxiety? First, like we did last time with the bivariate model, we want to pull these variables on its own and look at their distribution. Notably, our emotion regulation question, we have a guy up here that is strongly outside of any of the other observations. This looks like to be at about 400, so this is definitely something we want to look at and maybe correct for. Similarly, we have depressive symptoms over here, and you have all seemingly normal values that don't really go above 50. However, there's one guy up here that's above 800 that might really impact our data. And then we have our anxiety observed also that I noted in the first couple slides, that we have seemingly normal variance and then more spread out variance towards the end. And so I ran a correlation between emotion regulation and depressive symptoms, are two predictors. And with outliers, they have an correlation of about 0.01. Here's another graphical representation in the presentation of a histogram plot of emotion regulation and depressive symptoms. Like we saw in our univariate models, there's a strong outlier out here at like above 800 for depressive symptoms, and similarly there's one out here for emotion regulation observation, one that got a 400 score. So we really need to address these outliers before running any models. Again, here's our more graphical representations that can show us that we might have outliers. I want to pay attention to the residual versus the leverage. This tells us the suitability of our data given our model, and really shows us if there's outliers that are pulling our data. And it seems like there's two outliers, observation 123 and observation 30, that are strongly impacting our data values. So we need to address those. And it's also shown in our scale location, which is a measurement of homoscedasticity. We have two strong outliers pulling the data, and it's also noted in a residual versus fitted model too. After removing outliers, observation 30 and observation 123, you can see our plots look totally different than they did with the outliers. In all three plots, it looks like we have some normally distributed variance between our multivariate predictors and outcome variable. So now we can run our models. Here are two summaries of our multiple regression model. One is with outliers on the left, and the one on the right is with outliers removed. I just wanted to address the one on the left to say that we still do have significance at the 0.05 level. However, it is very dangerous to reject the null hypothesis without investigating any violations of our general linear model assumptions. The one on the right, when we remove extreme outliers, So we have much stronger betas, or that's expressed in the amount of change in y per unit change in x. And then our multiple r squared says that the variance of y, or 87% of the variance of y, can be explained by our two predictors. This also, we might want to draw caution, because if 86% of the variance of y can be explained by our two predictors, adding more predictors, there's not much variability for them to fight over. Also, these are measurements of personality traits, and it said in Abelson that we will not expect improvement in variance. Explanation is not expected over time given the measurements that we're asking. Lastly, we wanted to look at our factor variable of sex and look at the effect sex has on anxiety. Running a Pearson's product correlation, we don't expect too much correlation between sex and anxiety. It's only at 0.03, and the true score lies between -0.1 and -0.17. So, thanks for listening to my module.